We'll start by leveraging our design library to select a flange bushing and drag and drop it into this assembly. As it's dragged over the hole, it automatically seats itself in the hole through the use of smart mates, and we'll add another bushing at the bottom as well. Notice that there's a star on these bushings. This indicates that this is a smart component and contains smart features. Clicking the star inserts these smart features, as you can tell by the dimensions displayed on the screen. If we take a closer look, we can see that these features were actually added to the knuckle part to which it was assembled. We can dig deeper by using the section tool and see that the bore, fillet, and chamfer were added to our part. Let's add the smart features for the other bushing, and just like that, we've defined the proper bore for the bushing. Next, we can add the grease fitting by snapping it into position as well. We need to add a pin to our assembly. For models that are not in our design library, we can leverage Solidworks Search to find items anywhere on your computer. We are presented with all the models with expander in their name or description, and drag and drop the proper model into our assembly. This expander pin was created in two sizes. For this location, we'll choose the 220mm length pin. Solidworks automatically places the pin and asks us to verify that we want a concentric mate. The pin is positioned properly in the hole, but we can still move it up and down. Now we could measure this pin and do some math to position it with a distance mate, but a better way is to let Solidworks do this with the width mate. This advanced mate takes the selected faces and centers them to each other. That was easy, and I didn't even have to get out my calculator. Next, we'll leverage Solidworks Search and place a wear plate at the top of the knuckle. Adding another to the bottom is as easy as holding the control key and dragging and dropping a copy of the wear plate from the top to the bottom. A pin needs to be added to the holes on the left as well, so I'll just drag and drop this one from the feature manager and snap it into position with a concentric mate. Using the width mate again, we can center this one in no time at all. But this pin is too long for this application, so we'll leverage the configuration of the pin assembly and use the 150mm version, and our assembly is complete. Now a great way to communicate how an assembly goes together is with an exploded view, and this is simple with Solidworks. Let's grab these three components and just drag them out. Solidworks automatically spaces them, saving me the time of having to do them individually. We'll do the same on the other side, this time selecting the pin as well. Let's explode the grease fitting, but this time we'll reposition the triad to line up with its own axis. If a subassembly already has explode information, we can leverage these explode steps to save time. Finally, let's explode the wear plates and bushings using the same technique. That looks pretty good. Now we'll save the assembly and make an assembly drawing.